To prove the point, let's test our vulnerable REST API for SQL injection. Check if the API is receiving any controllable parameters. If there are any, let's check if they are vulnerable to SQL injection. If we identify a SQL injection vulnerability, let's also see how that can be exploited. SQL injection has been one of the most dangerous yet common problems in web applications. This will still hold true for REST APIs because, as I mentioned, REST APIs are also programmed just like web applications, and they are also susceptible to traditional web application attacks like SQL injection. For this demo, we are going to use View Profile Information API. Let's first go through the documentation and see how the API can be invoked. This is the API. It should be invoked using a GET request, and it needs a parameter called token. But how do we get this token? It's pretty simple. If you look at this login request, the login request is responding with a token. So we can use this token in the view profile request. So let's do that. If you remember, we have tested the login API endpoint and we have obtained a token earlier. Just in case if you have already closed this, invoke this particular API and you should see a token coming back in the response. So let's copy this token and let's put it in the notepad using token equals to the token that we have just copied, and that should do it. Now let's copy this and make sure the intercept is set to on, and let's paste the URL. Now the request is intercepted. Now let's give a right click and then send it to repeater. Now the request should be available in the repeater tab. Now click on send button and we should see a successful response. Now what we want to do is we want to check if this token parameter is vulnerable to SQL injection. So let's do that. To summarize what we have done so far, we have taken the endpoint which is invoked when the user wants to check the profile information. This request requires the current user's token. When this API is hit with the right information, we should see the information being fetched back in HTTP response in JSON format. There is a good chance that this request may be querying the database, so let's confirm and check if it is vulnerable to SQL injection. To confirm that the REST API is vulnerable to SQL injection, let's send a classic SQL injection payload. We can do that by changing this token to some invalid token, single quote, plus or plus single quote 1 single quote equals to single quote 1, and let's replay it, and there you go. If you observe the response, the request is considered valid even without a valid token, and we got valid response from the server. Let's change this request to an invalid one and observe the response. So let's make it 2 and click send. And there you go. It says no data found with this token. To confirm that our analogy is correct, let's once again change the payload to be a valid one and then click send, and we should see a response. This confirms that the token parameter is vulnerable to SQL injection. Let's dig deeper and try to extract more information from the database. For that, let's try to find out the number of columns that the table has. If you notice this, the API is interacting with some database and fetching these details from the database, and we want to identify the number of columns so we can craft a union statement and pass it to the database. We can do that by using an order by statement, but let's first go back to our valid request and put a single quote order by +1 --, plus. Let's click send, and if you see the response is still valid, that means column number 1 exists. Let's pass order by 2. Second column also exists. Let's try 3. That's perfect. Third column also seems to have some data. Now let's try 4. Once again, order by 4 is also working. That means we have 4 columns so far. Let's try 5. Fifth column seems to be existing. Let's try 6. If you see this, when we crafted the payload with order by 6, there is no data being returned. That means there are only 5 columns in the table. Let's verify that by logging into the Secure Store server's database. So I'm using a Ubuntu machine to log into the server. The server's IP address is 192.168.1.79. This is where the REST APIs are installed, and those REST APIs are using a MySQL database. So basically I'm logging in to that server using SSH as the user Secure Store. Now let's try to log into the MySQL server. The username is root and the password is toor, T-O-O-R. Perfect. We have logged into the MySQL server. Now let's check the databases. As you can see, there is a database called Secure Store. Let's use that. Now let's list out the tables that we have in Secure Store database. As you can see, there is only one table. Now let's query the contents of this table using select star from user. If you see this, there are 1, 2, 3, 4, 5 columns in this table, and that's exactly what we have identified using SQL injection as well. Order by 5 was working, but order by 6 was returning some invalid data because 6th column doesn't exist. To summarize, we have identified that there are 5 columns in the table that our API is interacting with. Now we can use the information that we have obtained so far to write a union statement so that we can write a select query and extract the data from the database. Let's see how we can do that. I'm using union select one, two, three, 4, 5, and let's hit send. If you notice, there are a couple of numbers that are being displayed here, 3, 2, 5 and 4. So among these numbers, we can use one of them to pass database functions and the data will be returned in place of these numbers. For instance, if I pass database of function instead of 2, this 2 should display the database version. Let's click send. There you go. There is a database called Secure Store on the server. So we are seeing that. Let's check the version. As you can see, this is the version that's being written in place of 2. Now what we are really interested in is finding out all the table names from the database Secure Store. We can do that by replacing this 2 with group underscore concat table underscore name, and at the end let's add from information underscore schema dot tables. Let's click on send button and there you go. If you notice, there are a bunch of tables that are returned, but there doesn't seem to be any user defined databases. If you remember, we know that there is a table called user. We have checked it by logging into the MySQL server. So let's check if there is any table called user returned. Interestingly, there is no such table. So we will have to change the query a bit. So let's change the table schema to our current database. To do that, we can add where table underscore schema equals to database of. So if you hit send, we should see a new table called user. This is what we were looking for, and now we have gotten this table user. So now let's use this table to extract the column names. That can be done by changing this table underscore name with column underscore name, and let's change tables to columns where table underscore name equals to user and table underscore schema equals to database of. This should work. If you notice this, there are a couple of columns returned: ID, email, username, password, and token. So there are 5 columns returned, which is expected. Now finally, let's extract the username and password of the users. To do that, we can remove this username and let's add 0x3a, which is the hex equivalent of colon, and password, and we want to extract it from the table user. So let's hit send. If you notice, the username and password combination is being displayed. It's not just for the user secure store, but it is also returning values for all the users. So in this case, there are only 2 users. One is secure store and the other one is attacker. And we are seeing the username password combination for both the users. This is how we can exploit SQL injection vulnerabilities in REST APIs.